Okay, so the first thing that I would like you to be aware of is I would like you to try to be here on time, all right? So that I actually start explaining everything and you don't come in and I have to tell you to put your microphones and everything else. All right. So Victoria, can you please mute your microphone?
Oh.
Thank you. Okay, so hi everybody, my name is Vasilios Adamos. You can just call me Vas if you like. Okay, so I will be your lecturer for this module. So this is cloud computing. You're all MSc students and you'll be with me from today until about the 10th of May for this module. All right, I will share my screen. This one. Okay, so the first most important thing that you need to know is Moodle. Okay, some of you will have been here in the previous semester and some of you will have just arrived here last week or whenever. Okay, so what I want you to do is I want you to go to Moodle, Port AC UK, and I want you to find the cloud computing module, and I want you to familiarize yourselves with all of the material that is in there. Everything is not in there at the moment. Okay, what I have at the moment is only essentially the first week, which is this week. So where it's the 8th of February. So it's the week that includes 7th to 13th of February. You will not see, so my view is different than yours. Okay, you will not see everything that's grayed out here because this is hidden, because it's not time for me to release everything, you know, all this information to you yet. So what you should be able to see is you should be able to see this week. So every time that we have a Zoom lecture, I will have a link to that lecture here on Moodle. Of course, the other detail to that is all of my Zoom lectures will be on exactly the same link. So I have a personalized link that I always use, so it's always the same. So whether you click on week 1 or week 3, it doesn't really matter. The Zoom link, and whenever you want to speak with me, is always the same. Okay, it never really changes. I will have the slides for the PowerPoint presentation that I do and all of the material that you need. And I will also have the lab sheets as well that you will need to do in the lab. Okay. What I also have available for you to use this semester is something called Discord. If you've never used it, Discord is a chat utility, essentially. Okay, so it's a program that you can use in order to go online. So I have a server, you can go onto that server and you can log in and you can basically meet with all of the other students. So it's a chat channel, essentially, all right? So you can find all of the other students that take my modules. So it's not only cloud computing students that you will see, you will find that there are channels. So there is one channel called cloud and there is one channel called VCC. You will have access to both of them. Of course, your primary interest is in the cloud channel, because that's where all of you, the students that take a unit with me on this particular unit, the cloud computing, you can go in and you can ask questions, and either I will pop in sometimes and help you, but more importantly, you can all help each other. Okay, so if you go in there, then you will be able to basically get some quick help if you're stuck with something and you can't wait until the next lab session so that we fix it for you. All right, so I will go through the slides first of all. So what we have is this. Let me organize my screen a little bit. Okay, so the module is called Cloud Computing. My office is in A202B. So this is in Anglesey building, second floor, room 2B. So there's a lab that's called A202, and there is a small office attached to that, and that's where my office is. However, if I am in the university, I will usually be in A2.net, which is the lab, the computer networks lab, where you will be working on. Okay. My email for any curious is simply name.surname@port.ac.uk, and I have the Discord link here. So you can just click on this and you can go to Discord, you can register if you haven't used it before, and then you can join my channel and try to either find me there or get some help from some other students in that. So how does the module run? So the module will consist of weekly 3-hour lab sessions. So you will either be on a Monday or on a Tuesday morning. You'll come into the lab for 3 hours, and I will be there to help you as well. Okay, so out of the 3-hour lab sessions, I might take up to the first 60 minutes at the beginning of the lab to explain any theory that you will need in order to complete the lab sets. Of course, this means that you need to be in the lab on time. Okay, it's very, if you're late, you will miss what I have to say, and what I say in the lab is not actually recorded. All right. Plus, it's a bit of an inconvenience for me if you have to come into the class and disrupt me while I'm explaining something to the students. Okay, to the rest of the students. So please try to be in the lab at 9 o'clock every day or before 9 o'clock. All right. So the module is assessed through 2 assessment artifacts, as we call them. The first one is the logbook, and the second one is the exam. Each are worth 50% of the unit, and I will explain in detail how they're actually assessed in later slides. We will use Linux, so we use CentOS 7 64-bit for the module, and we will be using Open Nebula, which is a virtualization, a cloud hypervisor, a cloud manager system that you will learn how to basically install, configure, and manage later on. All right. Everything that has to do with the module will be located on Moodle. So your first point for any questions, anything that you might not understand, go to Moodle, find the lecture slides or find the lab sheets and see if the answer for what you're looking for is actually there. The lab itself is called data.net. So it's in Anglesey building. It's on the 2nd floor. When you go up, you go left and left again. It's at the end of the corridor, pretty much. Okay, it's a lab that consists of 48 computers, and it's essentially an open space. It's an open access for you to use. This means that the lab times for you are 3 hours per week, whenever you're timetabled to actually be in the lab. And then you also have open access, so you can come whenever you like into the lab, as long as there isn't a class running in there. Okay. A red line has appeared on my slides by user iPhone 12. Okay, so please try not to play with the controls on Zoom. Just listen to what I'm saying. Okay. Right. So, so you can use the lab whenever there isn't another class running in there. All right. So the way that we organize this is we have 1 student per computer. So we have the first week, next week when you come into the lab, I will allocate a computer for you to use. Okay. So out of the 48 computers, you must always sit and you must always work on the same computer. So you get 1 computer on the first day, and you always come back to that same machine every week or whenever you come to the lab to work. All right. So once that happens, you will also be allocated a user account. So this means that when you sit on those computers, you don't log in with your actual student number, with your username, UP123456. The usernames in those computers are VM1 to VM10. Okay, so Monday morning users, for example, will have a login name of VM1. Tuesday morning users will have a login name of VM2, and so on. So when you come in, I will allocate a computer to you, and you will get a user account and a password for that user account that you can actually use every time you come into the lab. You work on the computer. All of your work is always saved on the computer, so nobody else should be using, or nobody else will be using that account on that specific computer. So for all intents and purposes, that computer is yours for you to use whenever you need to do any work on the module. Okay. polite request, please tidy up before you go. Assessment, so the logbook. So the logbook will be essentially an e-logbook. So it's kept during the practicals and it's submitted at the end of each semester, right after a mini viva. So what you will need to be doing is you need to be working on the computer where you're working on, and you need to keep a logbook of all of the work that you're doing. Later on, probably next week or the week after, I will release another video that explains in detail how I want you to work on your logbook, exactly what I want you to actually be doing. All right. The idea is that you work on your lab sheets, you complete all of the work there, all of the tasks, and every task you complete, you take a screenshot, you include it in your logbook, and you explain what you have done, what configuration changes you have done, what files you have created, and so on. And more importantly, why you have actually made those changes in the file. So by the end of the semester, you will have a logbook that will essentially include all of the work that you've done on the unit, okay, so that you can use it as evidence to prove to me that you've done on the lab sheets and you've done them well in the work and get assessed on that. There is a sort of structure that you can follow. So in the documentation of the logbook, you can have preparatory work, you can have methodology, configuration, testing results, and so on. It's not absolutely necessary, but it's a guide for you basically to understand what the best way to actually do this would be. All right. E-logbooks should be Google Docs that you will need to create, and you can share them with me if you like, so that I basically essentially give you some feedback on them during the semester if you like. So if you want, you can send me an email. If you do a couple of the lab sheets, you can send me an email and say, Vas, this is my lab sheet. Can you please have a look and tell me if I'm doing it right or not, if I need to change something and so on. Okay. At the end of the semester, so at the end of TB2, teaching block 2, we will have what is called a mini viva. So what I plan to do is after you're finished with all of your work, so this will probably happen in the last week of the teaching block. I think it's something around the 10th of May, 9th or 10th of May. Okay, so you will come into the lab and I will sit with you on your computers one by one, and I will check your logbook, first of all, and I will check the work that you've done on your computer as well. So this way, even if your logbook is not written in the best possible way, I will still be able to give you some marks by looking at the work on your computer as well. So if the work on your computer is detailed, it's all there and it all works, that will work to your benefit, and that will help you basically get the marks easier from the logbook itself as well. All right. Exam. The exam is going to be a computer-based test. So we use Moodle for this. We have a way to do this. So all you need in order to take the exam is a browser. Usually these exams happen from home. So this happened this January as well in the past exam period. So you basically will let you know which time the test becomes available, and then you can sit and take the test from your computer at home. It might be the situation that we might actually run a full normal exam period in the university. So it will all depend on how the pandemic goes and everything else. And we might make those exams actual exam events that you have to go into a class somewhere, sit on one of our computers and actually take the test, take the exam there. Okay, we don't know yet what's going to happen. Last semester, in the beginning of it, we said that it would happen in class, but then eventually by the end of it, it happened at home. So it's all the same to you. It doesn't really matter. You'll be sitting in front of a computer anyway, so it's fine. So the test lasts for 60 minutes and the questions are 50 questions. They are very quick and easy one-line questions. Okay, and everything in the questions in the exam will be from what we've done in the labs. All right. because it's what we've done in the labs, and because it's a computer-based test, and because we might give you the option to do it at home later on, it is an open book exam. This means that you can have your logbook open, and if you see a question and you're not 100% sure about the answer, you can actually refer to your logbook, okay, and try to find the answer in there. So it is an open book exam. So that should make it a bit easier for you as well. I will talk to you more about the format of the exam towards the end of the semester, closer to the time, and the types of questions that you will get and everything else. And of course, everything in the exams will be based on the lecture material and on the lab sheets. So everything that is in Moodle. There won't be anything in there that is not on Moodle. Right, let me try to do something. Great. I just wanted to get rid of the red line. Okay, good. So a couple of things about the module and what we'll be doing. So what is virtualization? In computing, virtualization refers to the act of creating a virtual rather than an actual version of something, including virtual computer hardware platforms, storage devices, and computer network resources. Okay, so essentially we're taking any computing resource and we're making it available through the network to our customers or to our users. So I have a question in the chat. Yeah, the exam will be in May. So exam period for us runs in May. I think it's going to be the last 2 weeks of May for it. Okay, so virtualization. Virtualization is the art, essentially, of offering services to people remotely on a virtual environment. Okay, so why is it useful? Because we can run multiple operating systems at the same time. So we can have one computer or one server or one data center or one data center farm, and you can be running multiple operating systems inside each of these resources at the same time, because you might have different needs, you might have different users that have different needs in regards to the operating system that they need to be using. We also have easier software installations because we can install programs much easier without actually being afraid about compatibility and problems. So you can test everything out, install it, and make sure that it works, which then leads to the fact that we have better testing and disaster recovery. So you can test whatever you're doing in a safe virtual environment without actually compromising your main server. So for example, let's say that you have a server that is running and you want to try a newer version of the software that's actually running a web server. You can take the virtual machine, you can clone it, because essentially we're just copying files around. You can run the clone, you can install the newer version of the web server software, check that everything is running as a test, and if it is running, then you can put that one into operation and bring your old actual server down, instead of actually working on an actual server, or more importantly, instead of taking down an actual server in order to do the update and bringing it back up again. Okay, and of course, one of the biggest benefits is infrastructure consolidation. So instead of having huge rooms or huge data centers that need to have lots of physical servers, one server per service, you can basically have one powerful computer, one powerful server, or one strong data center, and you can have tens or hundreds or thousands of virtual machine servers running in there doing everything. So what is cloud computing? Cloud computing is the on-demand availability of computer system resources, especially data storage and computing power, without direct active management by the user. So when we're talking about, for example, data storage, if you have an iPhone mobile phone device, or if you have an Android mobile phone, then you have storage either through Apple, through iCloud, or either through Google Drive. Okay, this is cloud computing. This is data storage offered to you in the company's cloud. So you upload your files, your photos, your videos, whatever, you save them there, without actually having to have storage on your own device itself. Okay, so the same goes with computing power. So let's say, for example, that you are a company and you run some CAD software, computer-aided design, and you need to be run some programs. You need to be running some programs that basically require lots of computing power because they're running simulations. Okay, you can be simulating an earthquake, you can be simulating the movement of the planets, whatever. All right, you can rent or you can own some space in the cloud, and you can use that in order to run everything that you need to run for that. So why is cloud computing useful? It offers efficiency, flexibility, and strategic edge. So efficiency, it offers accessibility because you can access cloud resources from anywhere on the planet as long as you have internet connection. It offers cost savings because instead of you actually buying hardware and running stuff, you can rent hardware resources somewhere and just run everything there. It offers security because it's a company that's renting the resources out to you. So you depend on their security policy and their security considerations, and you don't have to worry about it yourself. And there is disaster recovery in place as well, because the company that is running the cloud, they will have, or they should have, some disaster recovery plan in place in case you lose your data and so on. It offers flexibility because it offers scalability. So you can rent out one CPU, or you can, see that you can rent out 10 CPUs if you like. All right. So you can basically change the amount of resources that you are using. It offers tool selection, so you can have different software that you might want to use in order to run your business or everything that you're doing. And it offers cloud options and control choices. So it basically lets you manage the cloud as much as you like, or leave everything to the cloud management company itself. And of course, if you are a company, it offers you strategic edge because it helps with increased productivity, because it's more flexible, because you can do what you want and spend just the right amount of money in doing what you want to do with it. It gives automatic software updates. It makes you more competitive and increases collaboration because you'll be able to work as long as you have access to the cloud from anywhere on the planet itself. Okay, so the lab schedule itself, what we will be doing is we will have the unit intro, which is today. We'll have design and installation considerations. So basically how to install, to design and install a cloud system and how to install Open Nebula. We'll have operating system and environment installation and building the first virtual machine. So you create a cloud, you have a web interface that you run this cloud on, and you will create virtual machines inside it. You will explore that web interface that's called Sandstone in Open Nebula specifically. And we'll do a little bit of networking. So we'll show you how you can basically network all of your virtual machines between them so that you work on them. And then finally, you will build a cloud system. So you will build a small collection of virtual machines, and they will each offer different services in the network for you to use. Right. There is some recommended reading for this module because we're using Red Hat Linux Enterprise 7. Okay, so we're using CentOS 7. If you like, you can find this book. It's an orange book. And you can basically, I think we have copies of it in the library as well. Okay, so you can get this book and you can basically use it as a guide on the operating system itself. That would be especially useful if you've never used Linux before. Okay, so if you have never used Linux before in your life, then it will be a bit of a more steep learning curve for you. However, I will be here to help you with the commands and everything else. You will just need to put some extra time into the lab in order to play around with the commands of the operating system and find out how everything actually works in the operating system itself. When you get to the lab, other than the actual physical computer that will be there and we will allocate you with a student account, with a VM1, VM2, and so on, there will be a pre-configured, pre-built virtual machine inside that computer. So we use VMware in the lab to make those virtual machines, and you will be working inside that virtual machine. That virtual machine is called Prometheus. All right. And every time you come into the lab, you need to log into the computer, start up the virtual machine, and do everything in there. This gives you more flexibility in case something happens, you get sick, you need to isolate because of COVID or anything else. It means that you can still remote into the lab and work, or it means that if you want to work in your free time, let's say in the evening after 6 o'clock, you can connect and work on the lab. Give me a second, please. Something. 1 second. I'll be right back. Right, sorry about the interruption. The joys of working from home. So yes, so you will be working in a virtual machine that is already configured with CentOS 7. Okay, so it is already Linux installed on it. So if you have the book, and I think there's an electronic version of the book as well, you can basically get it and you can practice on it as much as you like. And of course, as I just mentioned with virtualization, because it's a virtual machine, even if you do break that Prometheus virtual machine, then we can still basically just recover it, just restore it. And this is one of the other reasons that we use them as well, is because even later on in the lab sits, if you do something wrong and you actually destroy your Open Nebula installation completely, we can still just recover the virtual machine, so you can start all over again and continue working on it, and it's pretty quick to recover. Okay. The second link on here is Open Nebula. So this is the documentation for Open Nebula. We'll be using version 6.2, the community edition. Okay. And you will definitely need to go into this and have a quick read about it. All right. And see what's in there. And we'll do this in a more guided way in the following couple of weeks as well, because I do want you to go in there and have a read and look at everything that's in there. All right. So this is the end of the first slide. So I'm going to have a look in the chat and see if you have any questions in there. Okay, so you have a WhatsApp group, that's fine. In conjunction with a WhatsApp group though, because I'm not going to use the WhatsApp group, you can also use Discord. Okay, so it's one of the reasons why we have Discord running, so that you don't depend on just joining a WhatsApp group. Discord is more versatile because you can get more help. You can get help remotely. You can share screen with it, and so on. Okay, so yes, you can join that WhatsApp group as well if you like, but you can also join the Discord channels that I have available as well. All right. So yes, thank you for that, Alexander. What's the difference between cloud computing and visualization? Haha. Okay, good question. The difference is that cloud computing is the evolution of simple virtualization. Okay, so you can virtualize a computer, or you can virtualize a bunch of computers together. Being able to manage all of those virtual computers together as a group, as a resource in itself, is what a cloud basically is. Okay, and also a cloud doesn't only offer virtualized computers, it can offer virtualized resources on their own. So you can have a cloud service that only gives out hard drive space. Okay, so that is something that you cannot do with simple virtualization. Clouds of course started from the fact that we can virtualize computers, but it's essentially the evolution of that turned up to 11, basically. Linux or Kali Linux. Okay, so Linux has lots of different flavors, lots of different distributions. Okay, the oldest and most established distributions are Red Hat and Debian. everything else, there were some other ones, Suzy and Manbeck, but that's ancient history nowadays. Okay, so most other distributions have evolved from those ones. So Kali Linux is a Debian-based flavor of Linux. Okay, however, in the lab, we will be using a Red Hat-based flavor of Linux, which is called CentOS, and essentially because Linux is free. Okay, Red Hat is a very big company nowadays, so they do create operating system and they charge you for the support for it. We don't need the support because we are the university and we know everything. Yay. So we use CentOS, which is essentially Red Hat Enterprise Linux, but without all of the Red Hat logos and without the support. Okay, so we'll be using, for all intents and purposes, Red Hat Enterprise Linux version 7. Okay. PDF link to this book? No, I do not, because I'm not allowed to. You need to find it somewhere and buy it. You need to find it somewhere and buy it online. Okay. Okay. I haven't looked this year to see if it has become available for free somewhere. I know that students have found it in the past for free in places, but I haven't looked. Okay. So we'll be using CentOS. Yes, we will be using CentOS. Okay. Great. Thank you. If you're not currently in the UK, you need to get on a plane and come to the UK. Okay. I've had a very big problem last semester with people wanting to work remotely because last year everybody was working remotely. Last year the pandemic was on its forte, so we had very big problems, so we had to work remotely. This year, only towards December, with the Omicron variant, we had to make measures a bit more strict, so we had to wear masks in the labs and everything. However, this has passed now. Okay, we don't even have compulsory masks or social distancing in the university. So for all intents and purposes, everything as far as the university and we are concerned is back to normal. So you should be in class. The only reason that I will allow anybody to start working remotely in the lab is if you're a new student and you have visa problems, for which you will need to show me actual proof that you have applied for a visa, you're waiting for a reply, and how long that reply will last. Okay, there is no way, absolutely no way, that will allow anybody to take the entire course completely online. All right. So just to be clear from the beginning, because this is a question that I will get asked a lot, because I got asked that question a lot last semester. Okay, it is exactly twice the workload for me to try to support students both online and in class at the same time. Okay, it's not, I cannot spend all of my mornings in the university and all of my evenings at home answering emails and helping people out with remote problems and so on. Also, last semester, it was proven that the remote connections were not very stable. So the way that we're connecting into the university now by using X2Go is quite unstable. Most importantly, we have students that lost their work. They lost their Prometheus virtual machine towards the end of the semester. So they lost all of their work and then got left with only any documentation that they had saved in their logbooks. All right. So we don't recommend it. We only use X2Go. We only have X2Go in case you need to be sick for a couple of weeks and you need to be home and isolate or whatever. Okay, but not as a regular resource, not as a regular thing for you to use all the time. Okay, so bottom line, if you're not in the UK, come to the UK as soon as you can. If you can't because you have visa problems, you need to show me, you need to send me an email with your application and everything else, and I will let you work for a limited amount of time on the computers remotely. If you don't want to come because of COVID and you're afraid, suspend your studies. Honestly, there's no other solution around it. Okay. If there is a problem with COVID and travel restrictions in your country, and you can prove that to us, then that's fine. Okay. However, we know that is not the case with most countries nowadays. and we know that everything is almost back to normal in most countries, and there are no flying limitations in the vast majority of countries around the planet. So generally, you need to be here. All right. It's also for your own benefit as well, because it's not the same. You're paying a lot of money to get an education from us, and you will not be receiving the same amount of care and attention from us if you are somewhere far away and not in the lab. All right. So it is beneficial for you. It's worth it. You're paying a lot of money to be here. You should be here and get a degree from here. Okay. All right. Okay. Discord channel, all you need to do is click on the link on the first slide of this presentation, or you need to click on the link on Moodle. Okay. And that will take you to Discord. If you're not registered, it will ask you to create an account. When you create an account, you can click on the link again, and it will take you straight into the channel. You join the channel, you basically join my server, and from there you will find the cloud channel where you can basically join. Okay, what type of server used for virtualization? So okay, it's a very detailed question, that's fine. So we will be using Open Nebula. Open Nebula itself uses KVM as the virtualization hypervisor. Okay, so we will be using Open Nebula, and it will sort, you will see how it will sort itself out with regards to the virtualization aspect of the services that are being offered. Implement SDN in our lab. Okay, yes, if you want, you can. So in your free time, so outside of the scope of the virtual machines of Open Nebula and everything that we're doing, you can actually play around in the lab and you can do whatever you like. In fact, if there is something that you want to think of as a project, or if there's something that you always want to play around with, I can help you. I can create a second Prometheus virtual machine for you, so you can have it as an isolated sort of playground, and then you can go in that, you can use that machine and test out whatever it is that you need to test. It's not a problem. The lab is there, and we encourage people, students, to actually try out everything that they need. Okay. OpenAI can do public both. It can do both. It can do hybrid at the time. Okay. Okay, Veronica, thank you. Thank you for that. Yes, so that's weird though, because I'm sure we had it. Okay, I'll check on that. Let me make a note and I'll check on that and get back to you about it. Okay. Also, yes, that's good. Yes, you can have the Red Hat guide essentially to the operating system, so that's just as good. What days are we scheduled for the lab? Whenever it's on your timetable. Okay, so at the moment it's looking like Mondays and Tuesdays, or Mondays or Tuesdays, 9 to 12. Okay, so I do have a problem that I have slightly more students that I can fit in the lab. So I have 112 registered students at the moment, and I can only fit 96 students in the lab. However, at the moment, I only have 83 participants in this lecture. It has proven in the past that we do get students that register and actually never take the modules. They do it to get visas or whatever and so on. So I will see how it goes first couple of weeks with regards to load and number of students. And if I need to, I will create a third lab session some other day whenever it is available. Okay, but generally, yes, whenever it says on your timetable is the best answer, really. How many lab seats will there be for this module? So if we go back, essentially we'll have 1, 2, 3, 4, 5, 6 lab seats. Okay. Yes, so your timetable will only say Tuesday because it's only once a week. Okay, I have lots of you, so I'm splitting this into 2 sessions. You need to come to the session that your timetable says you need to come to. All right, so it's 1 day a week. The best way to do it is to actually come into the lab, or you can in fact install VMware Player on a Windows machine on your own computers or laptops, and you can install CentOS in there because CentOS is free to download from centos.org. Okay, so you can download it and have it on your computer as a virtual machine, and you can go through either the book that I recommended or the operating system instructions, the manual essentially, that somebody posted on the chat here earlier on, and you can have a look there and sort everything out. Okay, and basically try to get some practice into it. Yes, so the lab is for you every Tuesday at 9 o'clock. This is your timetable. Yeah, that's it. Okay, it's VMware Workstation Player, which is free because VMware Workstation itself is not free. Okay, it's Player. So it's VMware Player 16. If you Google download VMware Player 16, it comes up and you can just download it and use it. Okay. Right, I do have a few more things that I want to explain. Okay, and I need to do this before we come into the lab because I need to explain to you the basic principles of operation of Open Nebula. All right, so let me drink a sip of water. Okay, so our cloud solution, what we will be using in the lab, is called Open Nebula. Okay, so this is an open source cloud solution. So essentially, instead of using Amazon Cloud or anything else, you will be installing, configuring, building, and maintaining your own cloud. So you will turn each of your computers in the lab into a cloud of its own. Okay, so in order to do this, we will install and configure Open Nebula. Now, in order to do that, your computers will need to have KVM. It has because it has, we've configured it this way already. All right, so you will have the KVM hypervisor essentially installed and running on your Prometheus virtual machine. And you need to install the software and run it. Before you run it and sort of know what exactly how it works, you need to know from an architectural point of view, overview, how the cloud actually works. What I want to concentrate mostly about on this document is this picture. Okay. So when you have a cloud, you have various components that make up that cloud. All right. At the very core of the cloud, you have your service network. So you have your switches and routers and everything that makes your cloud's virtual machines, your cloud nodes, start up, connect with each other, and connect with the outside world as well. Okay. So at the core, you have the service network. Now, in that cloud, one of those computers needs to be a server. So it needs to be an Open Nebula front end. So it needs to be the computer that doesn't run any virtual machines, but it runs one piece of software, which is the Open Nebula front end, and that is what manages all of the cloud. Okay. Sorry, I have a question.
Yes, so I just wanted to ask where Prometheus lies in this architecture.
Yes. So everything that you see here will be inside Prometheus.
Okay.
Okay, so all of these hosts and everything else will be, I will explain it a bit later on in more detail. Yes?
All right, thanks.
Good. And Raymond, yes?
Yes, sir. Some of us, sir, we don't have cloud computing in our module. That's the problem, sir.
I unhid it yesterday night. So did you check this morning and it wasn't there?
No, sir, it wasn't there.
Okay, so you need to check because I didn't have all of the material ready. All right, because I needed to test a few things in the lab before I make sure, because this unit was running completely online last year. So I had to check a few things in the lab before I get everything ready. And between all the marking and everything from the previous semester, it got delayed. Okay, so you have the Open Nebula front end. So you have one computer that is running essentially Open Nebula itself. Then, so this is a normal cloud solution, yes? You have data stores. So you have your file storage server. So you have one computer that has all of the storage, all of the terabytes or petabytes or whatever amount of storage you have available. And then you have your hosts that are the virtualization hosts. They are the computers, the servers that run virtual machines. Okay, and you can have, of course, one or more of them, and they will need to run the virtual machines that make up the cloud itself. And of course, they will connect with each other if they need to through the virtual machine network infrastructure that will be inside the host essentially. Now, when we go into the lab, our cloud will be as simple as possible. And by simple as possible, because it's only a proof of concept, only for you to see how it actually works, everything will be the same thing. So everything will run on one computer, everything will run on the Prometheus virtual machine. So you will install Open Nebula, the front end on Prometheus itself. The service network will be the actual bridge that connects the Prometheus virtual machine to the outside world. Any storage that you will provide to your cloud will be the storage space of Prometheus itself, those 200 gigabytes or 100 gigabytes or whatever space you have. And Prometheus will also be running KVM, so it will be available to start up the virtual machines that make up the cloud itself, and of course configure with OVS, Open vSwitch, configure all of the virtual networks that connect the virtual machines with each other. All right, so we will have in the lab the scenario that everything is on one. So all of this will be running inside Prometheus. When you do come to the lab, I will actually show you our little cloud, because we do have a little cloud in a rack in the back room, and you will be able to see in more detail in actual practice what a cloud actually looks like and all of the individual components that make it up as a cloud. Okay, so we have front end that executes the Open Nebula services. We have the virtualization hosts that provide the resources needed for the VMs, namely CPU and RAM. And you have the data store that hold the space, that hold the hardware space, that hold the images essentially for the virtual machines. And you have the physical networks that are used to connect everything else together. Okay. I won't go into too much detail about this, everything here. I think I've gotten you tired enough already. I don't want you to fall completely asleep. However, I do want you to read through this because you need to know. So we're talking about dimension in the cloud, how you can actually change the number of CPUs or the amount of memory or the amount of hard drive space or network cards and so on. I want you to look into the KVM nodes, what do you actually use them for. So we use them mainly for CPU and memory, so that we give those resources to our virtual machines. How the storage works, I will explain this more in the future as well. So the image data store, the system data store, so the space basically where the images of the virtual machines are stored when they're not running or where they are active and running and so on. And we'll of course talk about the network and everything else, and about the website of a Nebula Sans called Sandstone that actually runs the front end itself and everything else. Okay, so I would like you to read this document before you come into the class next week, so that you know how everything works in principle. I will explain this in the class as well, but don't just depend on this. I want you to understand the mechanism behind all of this before you actually start installing and working on it. Okay, so when you come in next week, I will explain this pretty quickly. So I will explain all of the resources and how we actually provision them in the cloud. And I will have the next lab sheet available with this Open Nebula setup, which I can show you a preview of it now, basically. So it's all of the commands and all of the configuration changes that we need to perform in order to install Open Nebula and run Sandstone and run the virtual machines that we want to be running by the end of it. Okay. Of course, I need to make sure that everything works 100% on this before I actually make it available to you. And that will be next week. So this is my job for this week. Do you have any questions before I go? Let me chat. Sorry, when I speak, I close the chat because it's distracting me. Okay, so that's how I do it. Vim workstation, yes. Hyper-V for virtualization. Yes, you can. All right, so if you are on Windows and you want to use Hyper-V, you can use it and you can install a CentOS, you create a CentOS installation in there. The beauty of virtual machines and virtualization in general is that it usually doesn't matter what your hypervisor is, as long as you can run the operating system that you want in there, it's fine and you can do whatever you like. Okay. If you have a licensed VM workstation, you can use that as well, of course, no problem. Okay. But in the lab, we already have VMware installed and Prometheus installed on it, so you don't need to worry about it in the lab. All right. Right, any questions before I go? Okay, so next week, I will see you all in the lab. Please try to be in the lab on time before 9 o'clock if possible. Okay, so we can sort out everybody on the computers that they need to be sitting on and get started with explaining all of the theory behind the installation of OpenNebula. All right, thank you very much, everybody.
All right, sir. Thank you.